Good evening, everyone. In this episode of Build with AI, we will be looking through Agent Development Kit, also known as ADK, and we'll also have a demo on automating patient intake in hospitals by leveraging the same toolkit and also the concept of multi-agent. Before diving in, a bit about me. I am Alagu Prakalya, machine learning engineer at ASAP. I am deep into LLM, AI, Docker, Kubernetes, and engineering. And in my free time, I play chess and I go out to recharge myself in the nature. And this is a brief overview on what we'll be looking in this particular presentation. First, we'll be looking on what agents are, what our tools are, and ADK itself. The Before diving deep into that, we'll also be looking into MCP and multi-agent architecture and the demo itself. So first of all, agents. So agents are basically LLM at the end of the day, but you give it the capability of function callings and also you leverage it with tools from the external world. So here there is a quite distinction between how a normal agent would function versus agent an AI agent would function, right? So you could see a normal agent would, let's say, first calculate which action would particularly maximize a parameter based upon the historical dataset name, and then it summarizes this calculation in a user-friendly manner, including what each of its thought process was, and then it would, uh, gather and then move on to the end result. But in case of agent agentic AI, it just calculates which action A would maximize the parameter B, and it just executes the action. So that's the basic difference between an agentic AI itself. You leverage the agent with additional tools from the external world. So, in brief, this is what an AI agent consists of. It has sensors or inputs. So obviously, it needs to take input. In this case, it's via the API, and it internally has planning engine, memory engine, like everything is like embedded within the single unit itself. And we also, the way we orchestrate or build the agent is like again through an external frameworks, API, and other retrieval modules. Moving on to what tools are, like agent is again at the end of the day LLM, it doesn't know everything, right? So you're just gonna call some endpoint of your function. So tools can be thought of as a stateless, a callable API at the end of the day, which has its own inputs and outputs. So now the agent then it can do the thinking process, calling process, and reacting to the same. Here is an example from LangChain, which uh, directly uses this REPL tool, which is used again to compute or to run the code, right? So here we basically instantiate the tool and you call the OpenAI model and then you leverage the tool within this tool's parameter and then you just click dot run. It will basically inherently use the tool within. And this tool can be anything. It can be any API, it can be a database, it can be any mathematical function or an automation that you created, or memory planning, or specific instructions too. Then formatting as well. So anything can be a tool here. Moving on to MCP. MCP stands for Model Context Protocol. Anthropic released MCP recently in November 2024. So the thing is like here the name as it suggests model context protocol. Context is the key here. So the basic capabilities of a GenAI model depends on its pre-training details, the training data, the model architecture and everything. So to make these particular models perform better and improve their relevance, we have to provide a good context to it. Now, context can be varied from different models to different tasks. For example, in a text based model like GPTs, prompt might be the context, and we will look into the token window. And in case of chatbot, we'll have the conversation history. And in case of increasing the relevancy, we have RAG integrated. But in case of image, you have text description again as a prompt, but also you have visual context provided, right? So in this case, you have cross model context within the text and the images. And similarly, speech and audio models, like there, the context would be the audio segments, the linguistic and the acoustic features like tone, speed, and the it influences the transcription and generation. So, like in short, context is the key factor that enables Gen AI as in a whole to produce relevant and coherent outputs. So, what happens like over the time, AI models can auto fetch the data to act as a context, and this is actually becoming true in the world of AI agents, right? So it just calls, queries, reads, writes, and then they evolve. So, like imagine here as like each data source as a server, it is like implemented in its own way, and also it can be uh, communicated through its own way, like a JSON RPC or anything, right? But there is no standard way for an AI model in this case, which is the client, in order to search for or the request the data from the particular server. So this is a case of fragmentation. So before MCP came into picture, which like in the world, like half of it are like that without the MCP only. So what we have is custom implementation for each of the application to hook into its required context, and that causes a lot of duplications. And there was inconsistent prompt logic, and then it basically increased the problem with the increase in the customized logic. So MCP it solves the problem of fragmented data access. It provides an open standard for connecting all the AI system with the respective data sources and tools also like repositories, business tools, development, and everything. Like nowadays, tools like Cursor AI, they also given their support to MCP kind of integration. Now, this is built based upon the JSON RPC, and we will be in the downstream. We'll look on uh, the core components of MCP itself. So, but that's the general idea over here. So, the core components being the client, which is the AI application or AI model. It can be an MCP client or an AI model. In this case, ADK will be used as an MCP client, and then we have MCP server with again a standardized schema. And for the communication protocol, mostly we will be using JSON RPC 2.0, and that's how we move on further. Now, since oh yeah, like let's man, the way it works is, as I said, it has contextual integrations in at real time, and it has a standard interface defined both at the source and the client level, and it also have enhanced functionality, and it also provide security authentication and authorization to some extent, but since it's a recent development, people are still contributing and then working towards it. And MCP server itself has features like prompts, resources, tools, and so on. So like its capability and then usage is very vast if used right. Now moving on to ADK, which is the Agent Development Kit. Again, it's an open source framework developed by Google. Uh, so it basically is like a plug and play kind of end-to-end SaaS platform where you could integrate frames like Crew AI, LangChain, LangGraph, and it also supports more other model providers. It's not only from Google. It leverages Light LLM, which also let you to access models like Olama from Anthropic, from Mistral and so on. So it has a lot of tools, and we will look more into deeper. Right. So these are the main core components of ADK itself. You could build agent, and the agent isn't like you could design your agent, the control flow of multi agents and the sub agents involved. You would also have your tools. You can create customized tools here, or leverage the existing tools like Google search, search engine, or maps, or any other external tool as well. And finally, orchestration. That's a very important part where, say, you build multiple agents and you have to communicate within, you have to let the enable the communication between each. It just takes care with one single line of code. And evaluation framework. In real time, evaluation is tricky, but here we could do a performance test, which we will be looking on during the demo. So basically here we have the base agent class, and then all of the other agents are derived of the base agent. You have LLM based, you could specify it for only reasoning or tool or only for transfer agent. And similarly, the you could orchestrate the way the agents are designed. It can be a sequential, parallel, or loop, or you could again bring in your own customization over here. I'll quickly show the blog. So here we have the get started documentation by Google. It's pretty detailed and everything. You could uh, like they have all user friendly notebooks and code snippets for you to try. And installations is also like very straightforward. It's with the pip install command called Google ADK, and that's all you have to do. And yeah, so this is a very detailed diagrammatic concepts, and these are the tools and functionalities that ADK supports. It makes everything more streamlined and simplified. And you also can find some tutorials and more about the agents, what agents each agent does. Like for example, diagrammatically, you could see this is how sequential agent works, and this is how you define. And loop agent, you basically have iterations given for each of the loop agents, so that it's basically a chain of thought, but how many times you think the same loop again, kind. Yeah, this is a very interesting part, and this I believe will increase the relevancy and reduce the hallucination in LLMs itself. And then we have parallel agents, which you could, it can be a kind of like a debate and decide kind of flow where you need, and there's more information about the tools, how you could deploy. This is another cool part. It doesn't only support deployment only to Google Engine. You could again containerize it, and then you could run on your Docker host or any on-prem platform infrastructure, right? So that's very cool. Evaluations are also same. Like you have the report in a JSON format that you could have, and here ADK also allowed you to create sessions and save sessions, and or save the same. So that's the cool part about ADK itself. And if you see, like if you don't have idea on what kind of agent you want to build, so here we have some sample agent here. In this particular thing, I will be deep diving into the travel concierge use case. Let's go back. So moving on to multi-agent system. What is multi-agent system? It's basically instead of having one agent, you'll have multiple agents. It's like you're having a second brain or a third brain, and we could also enable them to execute parallelly, real time, and we could manage our real time memory storage, everything in a very distributed and optimized manner. So that the end goal is like obviously it increases the relevancy of the output that we expect, which parallelly contributes to the quality at the end of the day and reduces the hallucination, which is like a huge problem these days. So we'll be looking into this travel concierge agent. So Google itself, they have provided a few ADK examples uh, in the GitHub repositories. One of those is the travel concierge agent. So here you see there's one root agent, and we have sub agents or multiple agents over here. So one for uh, planning the trip, one for booking the trip, one is for pre-trip, another for post-trip like feedback kind, and one to assist during the trip, and one to like just to be a friend and inspire you on what to do, where to go kind. At the end of this, like on the behind the scenes, it gets connected with the tools like Google search engine, Google Maps, Google Images, and everything. And here if you see, each sub-agent further has uh, several agent or based upon the flow for hotel bookings, and it has pre-trip agents, it has post-trip agents, and so on. Let's get into a live demo of the same. I have um, so if you see here, like here, this is a ADK samples repo, and you saw the agent garden over there in the UI, right? So basically all those are here, and this basically is the travel concierge. And ADK also lets you to run uh, the production and the end result locally using the ADK web. It just mocks everything to you locally, so you could test and feel happy about it. Let me go on and run. So I'm not going to dive deeper on how to set up ADK. I'll be looking into the application level of ADK itself. So the prerequisites for this, it's obviously the Google ADK package itself, and also in your Google Cloud, which you will get a free trial as well. Yeah. So you will have a free trial over here for a month, or for a year actually. Oh, sorry, I think it's for 3 months, I guess. And you'll have certain amount of credit, and this is like more than sufficient for you to play around and kick around. You could choose your projects and then just shoot one. And you'll also get the Gemini access use like via Vertex AI models, and you could use all the Gemini Flash models, multimodal as well. So you have to create this, and also you have to create a bucket in the Google Cloud so that your the command or the agent, whatever you store, the contextual information and the memory gets loaded to that particular bucket. So here, let me go, and then I have to type ADK web. It will it will launch me a particular web URL in the local host. So I'm opening over here, and then here we have okay, sorry, I think I'm in the, yeah, I am in the wrong repository. Cool. So this is the one. Let me launch again. Cool. And let me relaunch. So cool. Now we have the travel concierge agent. So this basically our agent, and here you see this all comes inbuilt, right? You would give a voice input, you would give video input, you can also give document, and you can also create session, delete session, stream your tokens and everything. Let me type hello. Let's see what it does. So in the background, if you see, we have this thing that started, and if you see it, we will have initial default state provided to the bot itself, like in this case the user profile, what their nationality, blah blah blah. It's all your wish, and then it just goes through what the request is. It just uh, it fills the prompt instruction with the given default date, and then you can see what are the agents that we have here. And we gave a message and basically have to route it to a particular, the root agent have to route it to a particular agent, so it just decides what it is. So here if you see, we could do this, and here it's transferring to an agent, and then we get the LLM response. So if you could see, we can do it. So let's say I was just back from a trip. I'm giving this because we saw that we had a post trip agent, and you could see there's a transfer of agent that happened, right? So basically, this is like your post trip agent that happened. Like you could go here and see the post trip agent that got activated, because ideally this is like, back from a trip, so ideally post trip agent should have it. So that's great. Now let's give image input. So I have a Gilby art over here, and let's ask, can you help me finding what place is this? I would like to travel to to travel there. So if you see there, we are using Gemini Flash model, which is a multimodal model. So okay, here they're not able to do, but then see, let's see, let's see, what does what place does this picture depict? And then let's attach this again and see. Okay, let's see. Hello, how are you? I'm just trying to manipulate the flow to back to the root agent. Let's see. Okay. So if you see here it is the all your logs. You could see how it is this. Okay, cool. So but earlier it was able to at least identify it was mountains and some kind of landscapes, right? So that's one thing. Or what we could ask is like in the readme. Oh, cool. So there's an example that these guys do. Let's see. Let's try the demo inputs. So it's going to the another agent. You could see the current state. Your create evaluation. Okay, you have there. Now let's see. Right. So if you see, like that's how basically all the sub agents and everything works. Right. See, you could see the shift to the planning agent. Let's create a new session, and hopefully, again, it's set reset to 0. I'm just wondering why this doesn't happen. What place is in the picture? Right. See, so now it was also able to read the image. It was able to find it's in architecture, it's in the mountain. So somewhere in the Southeast Asia, Indonesia, Malaysia, you could continue over there. So this is the basic idea of travel concierge itself. Now let's move on to our presentation further. Cool. Next, we will be looking into how to automate the agent, right? So in today's world, in hospitals, if you see, there's like each department handling 100 different tasks when a patient gets onboarded into the hospital. So how do we efficiently, instead of augmenting, automate it, right? The other thing technically you have to remember is like agent can be defined as a tools or sub agents. I'll quickly show how and why. And in case of sub agents, remember this, it can access the complete session. But in case of tools, it only accesses the necessary inputs. So it's a very minute detail to know in case of technical uh, implementation. So here, let me see. How do I? Cool. So if you see, there is a root agent, and here we'll have first the registration agent, which collects the identity, one for insurance, one contact info, another has a consent form. Then we'll have a triage agent, which actually routes to the relevant department, another for scheduling, the doctor appointment, ordering a test, it can be anything. And then finance, again for payment processing, billing FAQs, or copay estimator. Admission agent again with regards to the hospital, and monitoring agent with regards to vitals, alert detection, and this thing. So this is basically how we define sub agents. So it was the day earlier with the prompts, now with the agents, and then we basically are going to enable the same. So I've saved some time and then have already done that. So if you see here, oh, sorry. So under patient intake, you'll have sub agents, and we have all these sub agent defined. So our major agent will be this particular root agent, which is using a Gemini 2.2 Flash or one model. And you could see here we defined it as a tool instead of a sub agent. So we have all of those major sub agents defined here. We are the agent tool, and let's look into one. Let's look into, say, registration. We have again an agent, and over here, okay, let's look at, okay, we have the vitals monitor, our detection progress track with the digital tools again. So this is how we can do, and you could also use light LLM to change whatever model of interest that you look for over here. So basically you leverage an agent with a particular prompt, which will be the major first instruction, and you'll also have a default context provided initially as well. And then you will also have defined tools for the same. I used the help of AI code pair in order to fill up this code base quickly. So you'll have here your insurance verifiers, store patients info, and everything. Let's quickly do that. And also for fun, I have a Tamil bot here, which basically speaks or returns you in English. Let's say, hi, how are you? And I have asked it to like specifically do it in like Chennai kind of slow. Let me see. What are you doing? So this is an example of a Tamil bot. So you could use a sample bot for this as well. Now let's go to patients intake, and then let's go be hi. So it's like, welcome. To get started, we need to collect information, and then we will be looking into this. Let's say needs on my insurance. Let's see here what's happening. To schedule. Looking interesting. Probably there's some buffer. Let's restart the ADK web. Let me see. So I need to know about my health insurance. See if like that's particularly like redirecting you to finance agent, and then basically you can show the questions over there. Well, let's see. I to get a bit to activate. And similarly, since it also has inbuilt OCR recognition and everything, we could also have, let's say, the patient writes down the age, the name, and everything, because for onboarding perspective, it needs all the details, right? So all you have to do is upload it, and then it takes care. So here you could see the events, and let's see here. Okay, so let's go see. You could see how the function or event was calling and how it was been changing, and all your states you could track here. And you can also have an evaluation JSON. You could just create here, create new evaluation set, create, and then basically you could simulate the same and then evaluate your entire ADK scenario with the help of evalset. So yeah, that's pretty much it for ADK. Uh, Please explore the documentation and try to build on your own. And most of it is like detailed, and all of the examples and everything is available in various type of resources like Medium, YouTube, and blogs and so on. The cool part is you can also deploy this into Vertex AI and then run your agent real time. You could interact with your web like real time using voice, using documents and everything. So yeah, that wraps up this presentation. Thank you so much.